Ah, you blinked. All right. Okay, now we can get started with how proteins function. So, how do proteins function? So, guess what's in order to function? Protein must bind to another substance called a ligand. So, Ligand, Ligand, and don't forget it. Ligand, Ligand, and don't forget it. So, in order to function, proteins do need to bind to this magnificent ligand. So, a ligand, it's really simple. It's just a big word for a simple term. It's a ligand is anything that binds to a protein. So it's a pretty non-complex, put it that way. So a ligand could be an ion, could be a small molecule, large molecule, could be a carb, could be a protein, etc. It can pretty much be anything, but anything that binds to a protein is by definition a ligand. So that's first things first is what we need to know. But so in order for a ligand to bind to a protein, there's four specific characteristics of this protein ligand binding. So first off is specificity, second off is affinity, third is saturation, and fourth is competition. So let's start with number one, specificity. So specificity is essentially the correct shape of ligand to the binding site of the protein. So think shape when you think specificity. So it's the correct shape of this ligand, this thing that binds to the protein's active binding site. So let's say my hand's a protein, and here's the active binding site. So this ligand is going to come in. It needs to be the correct shape. So this is the best example here of the shape. But let's say protein's active binding site is a triangle shape. So what type of ligand would most likely bind? A square, a circle, or a triangle? So obviously, hope you answered this one correctly. A triangle would most likely bind to a triangle shape active binding site of a protein, because a square, or let's say a circle, into a triangle doesn't work. A square, I really can't make a square with the fingies. It doesn't bind in, but you get a triangle, boom, it's gonna bind like much easier because it's the correct shape. So that's specificity. It's like think of a certain puzzle piece. So obviously these ligand and protein shapes, the ligand shape and the protein's active binding sites are much more complex than circle, square, or a triangle. But think of it as a certain puzzle piece that connects to another specific puzzle piece here. So this exact shape binds, of a ligand binds exactly into the active protein or active binding site of the proteins there. So think of a puzzle connecting a one puzzle piece only connects to one specific another puzzle piece to form the puzzle. So in this case, the ligand needs to be the exact shape or have the same exact specificity as the protein's active binding site. So that's specificity. Now we're gonna also characteristics of protein ligand binding needs to be affinity. So affinity, simply stated, is strength of binding. So the stronger the bond, the greater the effect here. So the charge is often a major factor here, although not always. So, strength of binding, think of it like a magnet, I guess. So, you could put the positive end of a magnet to a positive end uh, with force, but it won't stay connected for long. So, you got a magnet here, a magnet here. If let's say they're both positive ends, you could put the positive. You're gonna have to hold it there. It's not gonna really snap in. But so it's the correct shape, let's say correct specificity, but not a high affinity, so not a very strong bond. So it'll have an effect for a moment, but since the bond isn't very strong, since it doesn't have a strong affinity, it's not going to bind, or it's not going to have that effect for very long. However, if you connect the negative end to the positive end, let's say like this, it's going to snap together, so it's harder to pull apart. So since it's a higher it's obviously the correct specificity, but since it has a high affinity to a high strength of bonding, a strength of binding, it's going to be harder to pull the magnet apart and essentially an increased effect. So two ligands can have the correct specificity, but whatever one has the greater affinity is going to have the stronger effect in the body. We're talking this could be multiple different molecules, compounds. The proteins are the pretty much help everything function in the body. So whenever we're talking about the ligand and protein, the specificity, the shape needs to be correct, but it also needs a high affinity or a strong affinity, which is a greater strength of binding there. But also, a ligand protein binding, a specific characteristic of this relationship is their saturation. So saturation, in anatomical terms, is the percentage of the binding sites of the protein that are occupied. So as the percentage of binding sites increases, the bonds increase, the effect also increases here. So if you have, let's say there's much more than these, but if you have 4 active binding sites of a protein, if one ligand is bound, there's 25% saturation. 2 ligands are bound, 50% saturation. Now, the more ligands that bind to the protein, the more binding sites of the protein that are occupied, the greater effect. However, when 100% of the binding sites are occupied of a protein, so say there's 4 active binding sites on a protein, this is just theoretical. If all of them are occupied, it's going to have the greatest effect. But here's the kind of catch-22. Once there's 100% saturation, the effect no longer increases. So say, here's the effect of 25%, here, greater effect at 50%, greater effect at 75%, but at 100%, guess what? The effect plateaus off because there's no more binding sites available for a ligand to bind to. So once 100% saturation is reached, the effect due to the effect plateaus off because there's max saturation. So the maximum amount of binding sites are occupied, which plateaus or balances off the effect. Now, if say a ligand gets removed from the binding site, the effect decreases. Now, if you add that back in, it's going to increase, and then it go from 75 to 100% in this scenario, it will plateau back off. But once 100% saturation is reached, the effect plateaus, but until then, the effect of increasing the binding sites or increasing the saturation, it'll increase the effect of the ligand binding to the proteins there. So just remember this simply is the more protein sites that are bound to, the more active binding sites that are bound to, the effect will increase. However, once 100% saturation is reached, the effect plateaus off. So that's the third aspect of protein ligand binding characteristics. And last but certainly not least is competition. So competition is when 2 or more ligands both have the correct specificity, so the same shape, and combine to the same exact protein here. So this will decrease a particular ligand's effect because some of the other ligand will bind to the same exact protein active binding site that the other ligand. So ligand, let's say there's ligand A and ligand B. So ligand A has the same exact specificity as ligand B. So ligand A is going to bind to the protein's active binding site, which will increase the effect of ligand A. However, ligand B is also going to bind to some of these binding sites of protein, which will, since ligand B is occupying a binding site of a protein, obviously ligand A will not be able to bind to the same exact binding site. So since there's less ligand A binding to the active binding sites of the protein, there's going to be less of effect. So as the competition increases, a particular ligand actually has less of the effect because it for the ligand to have the effect, and to have the effect on the protein and allow the protein to function a certain way, it needs to bind to the active binding site there. So think of it like this, anatomical or an analogy. As an analogy, excuse me, holy shit. But so think of being at a buffet. So just stick with me here; it all makes sense at the end. So let's say you want to be able to eat as much General Tso's chicken because you let's say you're eating all the different food at the buffet. You won't be able to eat as much General Tso's chicken because you're also eating, say, salmon or some sushi. So our bodies have there's only so much room, so the saturation ties a little bit into the competition as well, but we're going to focus specifically on the competition here. So our bodies only have so much room in our stomach, so in other available food, let's say the sushi and salmon is competing with the General Tso's for this space in our body, so there's only so much food that can go into the body. So whenever you're eating the salmon or sushi, you're going to be able to eat less general sows essentially there. So general sows might be ligand A, and the sushi and sushi and salmon might be the ligand B that's binding to the same exact binding site of the protein. In this case, it's the capacity of our stomach. So it's competing. The proteins in this case, less of a particular ligand is binding to a protein because other ligands are also trying to bind to that same active binding site. So the four major factors that affect protein and ligand binding are specificity, which is the shape, correct shape, affinity, which is the strength of binding of the ligand to the protein, saturation, which is the amount of binding sites of the protein that are occupied by ligands. So the more ligands that are binding to the protein, the greater the effect until max saturation. Then the effect plateaus. And competition happens whenever a particular, or when two or more ligands have this same exact specificity, so same shape, and they're trying to bind to the same active binding site of a protein. Obviously, the effect's going to be less because the less the ligand A can bind to the protein, the less effect there's going to be. And obviously, the more ligand A that can bind to a protein, if there's less ligand B, the greater the effect. But if you throw more ligand B in, obviously, ligand B is going to bind to whatever active binding sites of the protein it can attach to, so there's going to be less of ligand A binding, so it's obviously going to be less of the effect. So many medications in our bodies actually do play on this competition side of things. So it competes with our natural substances, our body. So say like a beta blocker will decrease the amount of adrenaline that can bind to a certain receptor. So obviously, if less adrenaline's binding, there's going to be less of the effect of the adrenaline there. So competition is a characteristic of protein ligand binding, but it also is a factor in medicine. So all these concepts, the specificity, affinity, saturation, and competition, they're extremely important parts of protein ligand binding, and they're the pretty much major characteristics that allow proteins to function the way that they do. We'll see you back here next episode. If you have any questions, please just comment below, and I'll get back to you, and we'll sort any misunderstanding out or lack of full comprehension out. So don't hesitate. Shoot out to me if you have any questions